Hi everyone, welcome to this episode of Keipert Labs. In today's video, we're going to be reviewing how we write chemical formulae. So thinking about, okay, what do we as chemists mean by a chemical formula, revisiting the concept of element symbols, and then looking at some of the tips or the ways that chemists will actually put a formula together. Okay, so thinking of chemistry is something that has its own language. So a field of science that really that we're thinking about different chemicals, we're thinking about different elements, and we need to develop a language that allows us to talk about them in a universal way, so that people across the globe can be talking about the same substance, that we can minimize the chance of getting confused. And chemical formulae, which is the plural of the word formula, allow us to do that. And so one of the things that we need to remind ourselves about before we can construct a chemical formula is the concept of element symbols. Okay, so remember, so that they're a short, we've looked at this before, you've looked at this several times over the last couple of years, but the idea that they're a shorthand way to represent elements. And so we get different types of kind of symbols. So they're mainly one or two letters. That there will always be one or two letters for ones that have been officially recognized. And so now what we've got some symbols that are just one letter, which is the start. So these are some examples I'll go through. So just as the first letter of their name. So H for hydrogen, U for uranium, C for carbon. Okay. All right, so first letter. And then we get other ones where we have two letters. So we get one uppercase letter and one lowercase letter. And the reason that we would have those is because we have 118 elements, but we've only got 26 letters of the alphabet. And so we need, if we're just going to use single letters, we're going to run out pretty quickly. And so we will often have elements that start with the same letter in their name, but we need to be able to distinguish calcium, chromium, chlorine, carbon, cobalt, copper, all of these ones that start with C. In the same way we need to distinguish, arsenic from statine, from argon, and bromine from beryllium, from barium. Okay, and so we add a second letter, which is typically the second letter of their name, or perhaps the second sound in their name, like in chromium and chlorine. Okay, they both start with CH, but that's a one sound in Greek, so R and L is the second sound. Okay, and then we get to other ones which are more complicated, where their symbol doesn't seem to have any bearing or relationship to their name. Okay, and so we get Na, Cu, Pb, W, Au, and K. But this is for sodium, copper, lead, tungsten, gold, and potassium, respectively. And part of the reason for that is that the names that we currently have for these elements is not always how they were known. Sodium used to be known as natrum. Copper used to be known as cuprum, or lead for plumbum, where we get plumbing from. Okay, these symbols that we established earlier on for how they were used to be known, and then we've revised the name over time, but the symbol has stuck, and so that we just have to be aware that those are ones that don't seem to match, and we need to keep an eye out for them. Okay, so now we have a look at what we mean by looking at a chemical formula. Okay, so I'm going to take the example of H2O, something that's very familiar to us for water. Okay, so it has the symbols which tell us which elements there are, and it also has numbers which tell us the ratio of elements. Like how many elements of this to how many elements of that, and so on. Okay, so we've got H and O to tell us that we have oxygen and hydrogen, H and O, for H for hydrogen, O for oxygen, and we also have a 2 that tells us we have 2 hydrogens and 1 oxygen in every 1 water. Okay, so I didn't write this as O, I wrote it as oxygen because my O and my 0 are going to look a little bit similar, so I didn't want to confuse you there. Okay, so that the numbers that we have here tell us the ratio of how many of each element is in the formula that represents that substance. Okay, and that these numbers this number that specifically that we're talking about is called a subscript. Sub being below, script being writing. It's a number that's written slightly down lower than everything else. Okay, and so that this number, this subscript, tells us how much of that element is present in that formula. Okay, so the idea, so subscripts, the subscripts tell us the number of atoms of that given element that are present in the compound or in that substance. And they come after the element they refer to. Okay, so that's an important one to be able to distinguish. So the 2 here refers to the hydrogen and not the oxygen. Okay, this is why I picked this example, because it's sandwiched between elements. If it's like carbon dioxide, it's more straightforward. You can kind of say, well, the 2 is at the end here, it can't relate to that. But so the idea with this is that the subscript comes after the element they refer to, and they cannot be arbitrarily changed. I've just written it, but I realise it's just gone off the screen for you. Okay, but so this idea of the 2 in water, we can't just all of a sudden decide, well, actually, I think water might be better off as H3O, or maybe as HO, or HO2. Okay, that we can't. They're decided by what we've measured about that compound in nature, and we can't just decide to change it. Okay, so that they can't be changed. Okay, what we'll see a little bit later on when we look at symbol equations is that there are other numbers in chemical equations that we can change that represent something different. Okay, so we looked at looking at an example of a formula. We looked at subscripts and the symbols. Okay, and now we're going to look at an extra dimension of some formulas that is necessary to show us how many things there are. Okay, so let's say so this will be a bit of revision. So let's say I have an ionic compound that's formed from copper 2+ and the nitrate ion, which is 1-. Now I recognise that I've got one thing over here. So if I look at this thing that we've established in the past, I've got one thing that has 2 pluses inside it, and this thing has a single minus. Now, in order to be balanced, I know that I must have a second one of these, which means this compound has a ratio of 2 nitrates, 2 of this ion, for every 1 of those. But so then in terms of how I write that formula, I'm going to need to somehow express that there's 2 of these. Now, let me show you if I just kind of go in and see if you can see what the problem is here. Okay, so I'm using a subscript 2 to show that I've got 2 lots of this, and then I've got copper. Now, I don't need to write a subscript of 1 in this situation, because I'm saying that if there's no other number, then we are assuming 1. Okay, can you see the problem here? The way that the subscripts read, I've got 1 copper, 1 nitrogen, and 32 oxygens, which is not what we're saying. That's not what this is supposed to be implying. So the presence of the 2 here is confusing. So the way that we can get around that is that if we actually put brackets around this nitrate ion and then put the 2 outside the brackets, it says I've got 2 lots of everything in the middle. Okay, and so now I've preserved the ratio of the things to each other, and it helps to cut out the ambiguity. Okay, or any kind of uncertainty or confusion that there might be. Okay, so now thinking, all right, well, let's have a look at a last example of how do you start from scratch to write a formula based on information. So let's say I'm going to talk about the compound methane, and I'm told that methane contains 1 carbon and 4 hydrogens. Okay, so I'm told that that's what the compound is like, and what elements are in there and how many there are. So the first thing that I need to decide is, what are the symbols that I'm going to be using in my formula? So looking at the elements I have, looking up their symbols and writing them down. Okay, so for carbon, I'm going to have a capital C, and for hydrogen, a capital H. So these are some of them you'll remember, others you might need to look at the periodic table to remind you. Okay, so it's always good to have one of those handy. Okay, and now we need to look at how many I have of each. Okay, so for carbons, I'm told I've got 1, Okay, looking at my information, and my hydrogens, I'm told I have 4. Okay, so I'm going to have a C and an H, and I'm going to have a 1 and a 4 in there somewhere. And now I'm going to look at subscripts to my formula. Okay, so putting subscripts in. So I'm going to write, I've got a carbon. Actually, I'll push this up here a bit. Okay, so I've got carbon. Now, because I've only got 1, I don't need to put a 1 down the bottom here. So then I can write the next one of hydrogen, which is capital H, and then I can put a subscript of 4 to show that I have 4 hydrogens in that compound. And there we go. I've written the chemical formula for methane. All right, thanks very much for watching. Bye for now.